Imagine a material so durable that it defies time itself. 4 millennia. That's the time it takes for a simple tire to return to dust. For decades, these abandoned rubber giants have symbolized our inability to manage our own waste. Too toxic to be buried, too dangerous to be burned, rejected by almost all waste management systems on the planet. But today, music, a spectacular transformation is underway. This very cursed waste is now eagerly sought after by engineers around the world. They now call it the black gold of modern road construction. In this fascinating exploration, we will follow the complete metamorphosis of a single tire, music, from the moment it is discarded, through its meticulous shredding and transformation into ultrafine rubber granules, to its fusion with molten asphalt to create roads of exceptional durability. Music. It is the story of a second life, of an industrial redemption that defies all expectations. Stay with us, because this odyssey will forever change your perspective on these rubber circles that we cross every day. Each year, our civilization discards more than 15 million tires, a figure so staggering that when we observe certain storage sites from the sky, we discover true black oceans stretching to the horizon. Music. Abandoned in nature, these rubber colossi practically do not decompose. Music. Worse still, they continuously release toxic chemical cocktails, transforming entire regions of the United States, Europe, and the Middle East into true hotspots of pollution among the most severe on the planet. However, from this environmental catastrophe has emerged a spectacular twist. Rubberized asphalt today represents an industry valued in billions of dollars. The figures speak for themselves. Just 1 kilometer of road can absorb up to 10,000 used tires, and the benefits are astounding. These roads become more durable, less prone to cracks, and reduce traffic noise by music approximately 6 decibels. Once an ancient symbol of pollution, the used tire now emerges as one of the most promising sustainable building materials of the 21st century. Every day, at the discreet yet constant pace of our modern cities, thousands of tires reach the end of their useful life. Neighborhood workshops, maintenance stations, collection centers, immense replacement platforms, all become starting points for this renaissance. Most of these tires have far exceeded safety limits concerning tread wear, elasticity, and load capacity. Left in the natural environment, they persist for decades with virtually no decomposition, slowly leaching organic compounds and heavy metals, becoming a permanent source of pollution for soils and groundwater. In many countries, a used tire is worth only a few cents when sold as scrap, but from the recycling industry's perspective, it represents a true urban mineral. Inside each tire lies a complex mixture: natural rubber, synthetic rubber, steel reinforcement, textile fibers, and chemical additives, materials that, when treated properly, can be recovered and reused with considerable economic value. The collection process is generally organized according to fixed routes. Specialized trucks equipped with high-capacity platforms and secure fastening systems gather tires from multiple locations to achieve optimal transport volumes. This approach not only reduces logistics costs, but also prevents tires from being stored outdoors, where they can trap rainwater and become breeding grounds for disease-carrying insects. Recycling begins with a crucial stage: the removal of the steel reinforcement embedded within the tire. This component allows the tire to lock firmly onto the rim during high-speed travel. But in a recycling line, this same steel ring becomes the biggest music obstacle. If it is not removed first, it can chip the cutting blades, break the drive shafts, and paralyze the entire shredding system. In the first stage, workers feed the tire into a specialized bead removal machine. Inside, a hydraulic hook system, music, capable of generating enormous pulling force, sinks deeply into the tire bead and uses brute mechanical force to extract the entire steel core in just a few tens of seconds. As you can see, the force is so intense that even the thick rubber body of the tire is violently twisted and deformed during the process. On average, each heavy truck tire like this produces approximately 2 kilos of high-quality carbon steel. Once separated, the steel wires are manually collected by workers, compressed into compact bales, and then transported directly to metallurgical plants where they begin a completely new life cycle. Music. Meanwhile, the remaining tire casing is now much more flexible and ready to enter the next stage, coarse grinding. Before the mechanical treatment begins, the tires go through a high-pressure washing system that removes mud, oil residues, and embedded gravel from the surface, protecting the cutting blades, music, and grinding shafts from premature wear. This may seem like a minor stage, but music plays a decisive role in maintaining the stability and lifespan of the entire downstream production line. Music. In the primary crushing stage, whole tires are fed into high-torque cutting machines, where slow-rotating alloy steel blades cut them into coarse chunks, measuring several inches in diameter. This low-speed cutting method minimizes heat generation, preventing the rubber from softening or sticking to the blades, while shaping the material into a suitable form for further processing. Music. The shredded pieces then move to a secondary grinding, where their size is further reduced and the internal steel reinforcement is mechanically fractured and progressively separated from the rubber. Music. High-strength magnetic systems recover the steel directly from the material flow, transforming this reinforcement into a valuable stream of recyclable metal. The final result is granulated rubber with a tightly controlled particle size, sufficiently stable to proceed to sorting or reuse. At this stage, the tire has completely lost its original shape and becomes a raw material ready for new applications in construction, transportation, and industrial manufacturing. At the end of the production line, all the material goes through a classification screening system. The particles that meet the required size move forward, music, while the larger pieces are returned to the mill for further treatment. Music. Among these products, the fraction ranging from 0.5 to 2 mm is particularly critical. This is exactly the size of rubber used to produce the rubberized asphalt that we will explore now. After crushing and screening, the granulated rubber from used tires still retains residual moisture, fine dust, and traces of impurities embedded in its structure. Music. These factors interfere with the way rubber interacts with hot bitumen, preventing the mixture from achieving the required bond strength and stability for high-performance pavement. For this reason, before it can be mixed into the asphalt, the granulated rubber must undergo a dedicated drying and heating stage to reach the ideal condition for mixing. Music. Inside the plant, the rubber granules are introduced into a rotary drying drum, a large steel cylinder placed at a slight incline and kept in constant rotation. Hot air, usually generated by burners fueled with natural gas or fuel oil, is introduced into the drum at temperatures ranging from 90 to 127 OC. As the material flips inside, moisture is progressively removed, while the surface of each rubber particle becomes dry and more chemically active, ready to interact with the hot bitumen in the next stage. In modern production lines, this process is closely controlled using temperature sensors and airflow regulation systems to prevent carbonization or loss of elasticity of the rubber. Many facilities also rely on indirect heating methods, keeping the rubber isolated from direct flame to preserve the internal polymeric structure of each particle. As a result, when the rubber enters the asphalt mixing phase, it can swell and absorb the bitumen more efficiently, forming a more durable, more elastic, and much more crack-resistant rubberized asphalt over time. Immediately after drying and preheating, the granulated rubber enters the mixing stage with the bitumen, where the true value of recycling is created. The bitumen is heated separately in storage tanks until it reaches a stable liquid state, usually between 160 and 190 OC, ensuring appropriate flow without degrading its chemical structure. The granulated rubber is then introduced into the mixing chamber in carefully controlled doses with common ratios ranging from 10 to 20% of the total mass of the binder according to the technical requirements of each rubberized asphalt formulation. Music. Inside the mixing unit, heat-resistant paddles generate a continuous vortex, forcing the rubber and bitumen into intense contact for a sustained period of 30 to 60 minutes. During this time, the rubber particles do more than just disperse. They swell by absorbing the lighter oils from the bitumen, a process that increases the viscosity of the mixture while significantly improving elasticity and crack resistance. These properties are particularly critical for road surfaces exposed to heavy traffic loads and constant temperature fluctuations. Music. In modern asphalt plants, the entire process is closely monitored through viscosity sensors, temperature controls, and residence time management to ensure an even distribution of rubber and prevent clumping. Some systems also introduce stabilizing additives to reduce phase separation during storage or transport. At the end of this stage, the rubberized asphalt reaches a homogeneous and stable state, ready to be used in the production of bituminous concrete, where discarded tires officially become an integral part of a new generation of resilient road infrastructure. Immediately after the recycled tire asphalt mixture is fully mixed, it is unloaded into specialized dump trucks whose hoppers have been preheated to prevent sticking or premature cooling. At the time of loading, the temperature is generally maintained between 132 and 149 OC, allowing the mixture to retain its workability and self-leveling properties during paving. Each truck leaves the plant along a carefully planned route, heading to a site where the construction crew has already prepared the base layer. Upon arrival, the driver raises the truck's hopper and releases the hot mixture into the hopper of the asphalt paver. This machine uses internal screws to evenly distribute the material across the width of the lane, while the leveling plate at the back places the asphalt at a precisely controlled thickness, most commonly between 3.8 and 7.6 mm, depending on the road design. Immediately after placement, steel vibratory rollers and tire rollers begin to compact the asphalt while it is still hot. The compaction sequence is carefully calculated. The steel rollers provide initial compaction and a smooth surface finish, while the tire rollers seal the internal air voids and enhance the bond within the layer. The entire compaction process must be completed before the mix cools below 82 OC, as the bitumen then loses its optimal bonding capability. In just a few hours, Music, the recycled tire asphalt, hardens and is ready to reopen to traffic. Roads previously considered to have reached the end of their useful life receive a new beginning, saving thousands of tons of raw materials and significantly reducing carbon emissions. A clear demonstration of the power of recycling in modern infrastructure. Over time, under the constant stress of traffic loads and environmental exposure, even rubberized asphalt progressively deteriorates with cracks and surface ruts beginning to appear. What is remarkable is that asphalt can be recycled repeatedly, almost without limit, while retaining its technical value. Even when originally produced from recycled tires, this material continues to circulate in the infrastructure system, transforming aging roads into raw material for the next generation of pavement. Once the asphalt slabs have been separated, wheel loaders or mini excavators intervene to begin the removal and collection phase. Operators carefully lower the scoop to the edge of each cracked slab. They then gently lift to raise the entire section without damaging the base layer underneath. Small pieces are gathered into groups before being loaded onto trucks, while larger slabs are broken using the scoop or steel bars to facilitate handling. When the asphalt remains tightly bonded, workers assist with shovels and pry bars to loosen the edges, allowing machines to work faster and more efficiently. Each scoop can hold between 90 and 180 kilos of asphalt, and in just a few hours, dozens of tons of material are cleared from the road surface. The trucks are weighed, assigned batch numbers, and registered with their excavation zone before leaving the site, ensuring complete traceability of the wrap, reclaimed asphalt pavement for future quality control. Once the surface has been completely stripped, the equipment performs mechanical sweeping and base leveling to prepare for fine milling in the next stages of recycling. Although it may seem like a simple task, this phase determines the accuracy and efficiency of the entire recycling process, where each slab of asphalt is separated, collected, and prepared for its journey of rebirth. After the old pavement is removed and transported from the site, all the material known as RAP, reclaimed asphalt pavement, is sent to a recycling plant. Here, every ton of used asphalt begins a process of separation, cleaning, and size standardization, preparing for the next mixing stage. The first step is the removal of impurities. Trucks unload the RAP into a feed hopper, where the material moves along a vibrating feeder that separates debris, dirt, scrap metal, and concrete fragments collected during milling. Large pieces of metal are removed by an electromagnet, music, while the remaining material enters the impact crusher, the heart of the entire treatment line. Inside the crushing chamber, high-speed hammers, rotating at 18 revolutions per minute, continuously strike the asphalt against fixed impact bars, breaking the pieces and separating the aged bitumen from the stone aggregates. Adjustable impact wings allow operators to fine-tune the space between the rotor and the bars, controlling the output size, typically from 1.3 to 5 centimeters, according to regional mixing specifications or manufacturer guidelines. Music. After crushing, the material passes through a multi-level vibrating screen for classification. Oversized particles are recirculated back to the crusher, while appropriately sized aggregates are divided into groups: coarse RAP, fine RAP, and fine mineral powders. Some plants also include an air separator to remove light dust, ensuring cleaner aggregates and improving binder adhesion during remixing. In modern facilities, the entire process is automated and monitored by sensors that track vibrations, temperature, and material flow, ensuring consistent quality of the RAP. On average, a single plant can process between 100 and 300 tons of RAP per hour, recovering up to 30 to 40% of material ready for direct reuse in new asphalt mixes. This is one of the most critical stages of asphalt recycling, where old pavement is reborn into a clean, uniform, and valuable resource, ready to enter the drying and heating phase of a completely closed-loop process. Rubberized asphalt is much more than just a technical improvement. It is a shining demonstration of how humanity can transform an environmental problem into a practical solution. From tires previously considered worthless, we create longer-lasting roads that are more pleasant to drive on and infinitely more environmentally friendly. As technologies like this continue to expand, they not only change the way we build infrastructure, but also reshape our thinking about materials previously labeled as waste. The value does not lie in the appearance of a material, but in the way people choose to use it. If you want to continue exploring the hidden engineering stories behind global industries, be sure to like the video and follow our channel.